such a fun topic to kind of explore the dynamic nature of metabolism and insulin resistance. Insulin resistance has two aspects of itself. One is the pathological side, which is the side of it, which is the version of insulin resistance, which promotes chronic disease, these so-called plagues of prosperity, Alzheimer's disease, fatty liver disease, hypertension, heart disease. All of those are consequences of insulin resistance and the pathological version of it. But there is a physiological side of insulin resistance, which is when the body becomes acutely insulin resistant to serve a specific purpose. And that is the insulin resistance that we're touching on now when we talk about the changes, particularly during the menstrual cycle. So a woman will become relatively a little more insulin resistant during the actual menstruation. Like right after, progesterone has come up. Well, I should say it's kind of right before. It's right as the endometrium is kind of at its thickest and progesterone is peaking. Then she is at her peak insulin resistance during that cycle. Now, it does not get to the point of like clinically, problematic, but if her insulin resistance were humming along throughout the month at a very, very low level, or let me say it another way, she's very insulin sensitive throughout the entire cycle. And then with those few days, right around the time of ovulation and progesterone has come up, then she becomes a little insulin resistant. And then as she starts to shed, there's no implantation, no fertilization, then things go right back to insulin sensitive. But that's because progesterone is a hormone, unlike estrogens. The estrogens, how can I say this best as I start weaving in these numerous topics? I'll try it this way. The estrogens tell the body where to store fat, but not how much fat. That's very, very important. Overall, estrogen actually has a fat burning effect. This is why at any moment in time, a woman is burning 40%, relatively 40% more fat than a man is. Now, a man has a higher metabolic rate just because he's bigger, but a woman, relative to her body weight, will be burning 40% more of her energy from fat. And that is very, very heavily dependent on the estrogens. So estrogens tell her where to store fat, but also tell the body to rely on that fat. So a lot of fat is going into those fat cells, but a lot of it's coming out to be burned. So there's a high turnover. That's a very healthy way to store fat. Progesterone tells the body to store fat, and it does so by leveraging insulin. And so during that period of time, progesterone promotes a slightly insulin resistant body. And that means insulin levels have to come up a little higher to overcome this subtle insulin resistance, throughout the entire body. But that doesn't happen at the fat cells. The fat cells do not become insulin resistant. And so now this higher than normal insulin promotes a slightly greater than normal fat storage. So hormones like progesterone and insulin tell the body how much fat to store, whereas the sex hormones, well, progesterone's a sex hormone, so the estrogens and androgens tell the body where to store fat. And those are not the same thing, of course. So there is that acute little moment of insulin resistance, nothing to be concerned with during that moment of the month. And then after that, after her fertile years have passed her by, and as you noted, at that point, the aromatase expression changes in the ovaries and her estrogens production starts to drop a lot. At that point, she's lost that kind of fat-friendly and even protective effect of the estrogens, and now she's sort of subject to the whims of the androgens a little more with regards to fat storage. Now, this is not to say her androgen levels go up really high. No, they don't change that much. It's just
but
that
it's
the
the relative amount. It's the
That's
relative
right. Yep.
amount. Yeah.
Perfect. That's perfectly right. And so now her body just starts to store fat in more of an androgenic way. In other words, as you perfectly mentioned a moment ago, more centrally. And she can literally start to lose some of that fat that she had been storing on her breasts, hips, and buttocks, because the estrogens were what was determining where that fat should be stored. And that then starts to, in a way, that at that point, the woman starts to lose the metabolic protection that the estrogens had provided her. Estrogens, in a way, provide a metabolic protection for a woman, allowing her to basically avoid the consequences of her fat tissue. the metabolic negative consequences. She's been protected from it. Estrogens help her body know what to do with fat and handle the fat in a good way. With the loss of those estrogens during menopause, now she's no more protected from the fat than her male counterpart is. Her risk of disease from fat tissue starts to match that in the males. So I like to joke that that's when the woman loses her metabolic superpowers and becomes a mere mortal like the rest of us men are.
And that's actually why
already.
we see things like, you're talking about like like when we look at the onset, let's say, of cardiovascular disease, which you can argue is a disease of fat and lifestyle, let's say, we see this phasic shift where men will, sort of reach the point of inflection or no return, maybe is a way to say it, earlier than women, but just the same amount of women reach it. It's just like, let's say 10 to 15 years later. And it usually that increase in risk starts at the point of menopause, to your point, where the estrogen, like that estrogenic protective effect, let's say, is now gone. And now she's a bit more maybe androgenic, potentially a bit more. Her body behaves, and this is not to be meant in a derogatory way, but it behaves more male, which also means, like, we're going to get to actionable items in a moment, but it also means that she can start to behave in some of the tools and applications. We don't have to be as stringent around fertility and worrying about the impact on the oocyte and the mitochondria. Like, she can actually have more aggressive fasting. She can actually do a ketogenic diet for a longer period of time, let's say. Whereas for a woman who's in her fertile years, one of the things that I wrote about in my book, I know that it's reflected in your book, Why We Get Sick, is that women who are in their reproductive years do have to change the way that they eat and to a great, and I would also say train, when they're exercising differently through the cycle to match some of these metabolic, or I'll say these ever-changing metabolic environments as well. I had a question for you. I just wanted to come back to estrogen and progesterone because I was making notes as you were talking. So estrogen tells the fat where to go. Progesterone says how much, and it does so by leveraging insulin. And you said that women are burning 40% more fat than our male counterparts are. Does that have anything to do with the increase? Like, women typically have a higher percentage of type 1 muscle fibers, which tend to be more, we'll say, fat burning, let's say, than they are glycolytic. Is that play into the mix as well, or?
That's a really good point, actually. That might be part of the demand for that fat from the fat cell, but you can actually, this goes right to the level of the fat cell. If you were to take a fat biopsy from a woman and a fat biopsy from a man, and if you were able to put those fat biopsy tissue, the fat tissue, in a little beaker in a science lab and keep the tissue alive and active, it would literally be secreting 40% more of its fat at any moment than the fat cells from the male, from that same location. You pop it out of the belly. So you invoking the muscle, that could be part of the demand. In other words, the pull, where there could be a differential expression from the female muscle cells. I don't know this, so I'm speculating, but muscle tissue releases a myriad of hormones as well. And it could be that that there's a difference in expression of hormones hormones like FGF21, for example. That is a muscle-derived hormone that can activate lipolysis. I don't know about that. I can't speak to it, but I do know that the estrogen effects simply enhance lipolysis on their own. So we can remove the muscle from the equation, although in the whole body we can't, and I believe it's very likely relevant. But just sticking with the sex hormones and the fat cell, estrogens simply activate lipolysis at a higher rate, especially at subcutaneous fat cells. And the differences go even further. The estrogens not only tell the body where to store fat, but also how to store it. One of the reasons females can store more fat than males pre-menopause and be much, much healthier is that the very nature of her fat cells is different because of the estrogens. Estrogens, specifically, particularly at the buttocks and hips, much to the woman's dismay, perhaps, provide an almost limitless phenomenon of hyperplasia. So anytime the insulin or the progesterone is telling her body to store more fat, because they control how much fat the body stores, the estrogens will tell those tissues, buttocks, the fat tissue in the buttocks and hips, hey, the moment the fat cell gets a little big, just recruit another fat cell and recruit another fat cell and another fat cell. So she continues to store her fat there by making new fat cells. That might sound like a problem, and it might be a problem if she's trying to squeeze into her college jeans that she used to wear. But metabolically speaking, it's magic, because when fat tissue is growing through hyperplasia, the fat cells stay small and they stay very metabolically healthy. In men who have relatively much lower levels of estrogens, there is none of this hyperplastic stimulus. And so his fat cells, if there is a pressure to grow, not through progesterone, of course, exclusively through insulin, they almost totally grow through a process of hypertrophy. And the fatter the fat cell gets, the sicker it gets and begins to promote insulin resistance throughout the body. So the protective effects of the estrogens go through multiple levels here, not only burning fat at a higher rate at any moment, but also altering the very nature of how she stores fat at those locations particularly. But again, this plays into part of the pathology, if you will, of menopause, where she loses that another protective effect. So not only is she losing the protective location, the storage in the subcutaneous depot, relatively shifting to store more viscerally, but then as she is storing more fat, her fat cell number starts to go down. But again, that's not a great thing, because that does mean, in the absence of any other changes, and Stephanie, you mentioned it very, very well, to me, there's an opportunity there for lifestyle change. But as she starts to lose her fat cell number, if she continues to eat the same way and live the same life, then her body still wants to store that fat. It just has to store the fat now in fewer fat cells, inducing a greater and greater hypertrophy, and perhaps storing the fat in tissues not designed for long-term fat storage, like the liver and the muscle, etc. So she loses multiple protective benefits. Again, that all plays into why I say estrogen allows the woman to be a metabolic superhero. And with the loss of that estrogen, she just becomes a mere mortal.
So we have, hyperplasia, just in case my Betty's you're lost. So hyperplasia is more fat cells. This is under the influence of estrogen, let's say. But this is as you were saying, like much to her demise, more fat cells, maybe not so great for the bikini, but it helps her stay metabolically healthy. When we transition to, let's say, a lower estrogen environment like peri or menopause, then we don't have that ability to keep the fat cells small anymore. We have the same kind of, maybe we're a bit more set in the number, but the individual fat cells are becoming trophic. They're becoming bigger and bigger and bigger. And that's when we can get, and maybe you can touch a little bit on like the fat cell, like that adipocyte now is starting to get like really, really big and inflamed. It's going to start leaking, let's say, pro-inflammatory cytokines and the ceramides and like all the things that you talk about in your book, where then we see this like pathology of inflammation, like this like creep that happens at menopause.
Yeah. Oh man, gosh, you've become a master. You're invoking all the right ideas here. Yeah. So when the fat cell gets too big, we almost have to feel bad for it, because it starts to try to survive. But the two ways that I'll mention in a moment in which that it leverages in order to survive end up, unfortunately, creating metabolic havoc for the rest of the body. So the two things, you mentioned the inflammatory cytokines, so let's start there. When the fat cells are hypertrophying too much, they begin to actually push each other further and further away from capillaries, blood vessels. And the capillary is the site of exchange for a cell. It's where it gets new oxygen. It's where it dumps off its CO2 from its metabolism. It's where it receives new nutrients or gives out its nutrients. And so suffice it to say, a cell has to be very, very close to a capillary in order for that to work. But as the cells are hypertrophying so much, now it used to have maybe a micron or two away from a capillary. Now it's getting several. It's increasing multiples in distance. That is catastrophic. It will literally die. It will suffocate. And it will undergo a process called necrosis. It will rot and die. And we don't want that. So the hypertrophic fat cell, who senses that it's becoming increasingly hypoxic or reduced in oxygen access, it will start to secrete pro-inflammatory cytokines, because some of those cytokines will induce the production of new blood vessels. So this is the big fat cell's way of saying, hey, capillary, you're too far now. I'm sending you this message. Bud off, branch off a little capillary to come out this way so that I can start to get some blood so that I don't die. Now, that helps the hypertrophic fat cell survive, but at the same time, it's secreted a whole panel of pro-inflammatory proteins, only some of which, largely one, is actually helping with the improved blood flow, but it just sort of belches them all out. And then it's all the rest of these pro-inflammatory cytokines that begin to promote a subtle but relevant inflammation throughout the entire body. Like the body is fighting a mild infection in the absence of any actual infectious agent. It's just this fat cell doesn't know what else to do. At the same time, the fat cell is reaching a point of maximum dimension. And I know of no comparable effect where you can take a normal-sized fat cell and in the presence of insulin to promote its growth, it can grow to 10 times its volume. And unlike any other phenomenon in the body, where it will grow 10 times. And at that point, it begins to reach a point of maximum dimension, where it simply starts to tell itself, I can't grow anymore, or I will overwhelm the ability of the cell membrane to hold us all together, and we will literally burst apart. And so the hypertrophic fat cell starts to tell insulin, you want me to keep growing. And so while I can't stop you from shoving the nutrients in, because it can't really, I can stop you from preventing me from breaking down my fat and leaking out my fatty acids. So that's what happens. I know I got that a little complicated with a bunch of double negatives, but basically insulin would tell the fat cell, don't break down any fat. In other words, inhibit lipolysis. Lipolysis is the technical term for breaking down stored fat. But the hypertrophic fat cell says to insulin, I can't stay this big. I can't continue to grow like you want me to. So fat keeps coming in, but now the hypertrophic fat cell starts letting fat out. And so we have two phenomena occurring in the body overall because of the hypertrophic fat cell. One, the body's becoming ever more inflamed. And two, the body's becoming filled with circulating fat that it doesn't know what to do with. Those free fatty acids that it can't burn because insulin's too high. And if insulin's high, the body doesn't burn fat. It can't really store in the fat cells anymore because the fat cells are already too full. And so then you have this more ectopic fat deposition that we've both alluded to already, where you start storing fat in tissues that are poorly designed for fat storage, creating things like fatty liver disease, and that could progress into full-on steatohepatitis and cirrhosis and liver failure and myriad other problems. But it all comes back to this series of events, a fat cell that has become overfull, or in other words, hypertrophic. And then to bring that back to the female phenotype, it starts to happen with the loss of estrogens.
And is there a way to make those hypertrophic fat cells insulin resistant? Meaning, is there a way for that cell that's like growing and growing, is there a way to down-regulate its sensitivity to the effects of insulin?
Yeah, it's no. In fact, you can't. That's a really, really good question. You can't do that. And I would submit you wouldn't want to. So what you would want to do, rather than just correcting the fat cell's ability to respond to insulin, what you'd want to do is allow it to respond well to insulin. And while you cannot control the effect of the fat cell, you can control the insulin. So don't look at correcting the fat cell. You can't. It's out of your hands. You can correct the insulin. And that comes back to all the strategies we've talked about before, and I know you've talked about in other podcasts. So we can't blame the fat cell for just doing its job, and so we shouldn't try to correct it. What we should try to correct is the stimulus that continues to aggravate the fat cell, because that we can correct.